Hey there, in this video we'll be discussing about potential difference and its units. When we consider the flow of current in a conductor, we are only worried about how the current is flowing across this conductor. Hence, we do not need to know the potential at one particular point in the circuit. Rather, we would like to know what is the difference in potential across 2 points in a circuit. Potential difference is sometimes denoted by PD. It is also noteworthy that potential at a point potential at a point cannot be measured, cannot be measured. We rather end up measuring what potential difference is. This is much more easier. It is easier. It is easier to measure potential difference. Potential difference across 2 points. Across 2 points in a circuit. So this is something that you need to note. We do not have a measuring device to measure the potential at a unique point. Rather, we always measure the potential at one point with respect to another point in a circuit. So, similar to how we define potential at a point, the potential difference between 2 points is defined as the work done, the work done I'm writing as WD, the work done in moving a unit positive charge from one point to another, from one point to another. So this is the definition of potential difference. It is very similar to the definition of potential. The only difference over here is that we measure it between 2 points rather than between infinity to one point, as in the case of potential. An important note that you should make at this point is that both potential and potential difference are scalar quantities. Are what? They are scalar quantities. What do you mean by scalar quantities? Scalar quantities, let me write this quantity. Scalar quantities are those which have only magnitude and no direction. Alright, so this is an important note that you all should all make at this point. We get back to our circuit over here and we say that between points 1 and point 2, the amount of charge that has moved from this point 1 to this point 2 is Q coulombs. This much amount of charge of Q coulombs has moved in time t seconds. If the work done in moving this charge Q across from point 1 to point 2 is W joules, we can conclude by saying that the potential difference between position 1 and 2. We are going to denote it by this notation, V1 minus V2, that is potential at 1 minus potential at 2, or it is nothing but the potential difference between 1 and 2. This potential difference is nothing but the amount of work done, W, per unit charge. So if I divide by charge Q, I'm going to get the potential difference between points 1 and point 2. Just like we did in the case of potential, the units of potential difference is derived from the unit of work, which is joule, and the unit of charge, which is coulomb. This is a derived unit. These are the units in the SI system, but we also use capital V, similar to the case in potential, where V is nothing but volt. So you see, potential difference is very much similar to the case when we define potential, but as the name suggests, potential difference, it is the difference of potential between 2 points in a circuit. Now at this point of time, a question might crop up: how does one measure potential difference? So the potential difference between 2 points is measured with the help of an instrument called the voltmeter. Here is an image of a voltmeter. We see that the voltmeter has two knobs through which we can pass leads that connect to the circuit. It should be noted that the voltmeter is always connected across the 2 points, in the circuit, in parallel, as a parallel connection. So what should you take care of over here? You should take care of that the positive terminal of voltmeter is connected to the positive, to a higher potential in the circuit, and the negative knob of the voltmeter is connected to a lower potential in the circuit.